All right, here we go. I need to set up, you're seeing the pet right now, but I'm gonna go back here. First, let's see who's in the chat. A couple of people seem to be here. Harley gifted a membership. Okay, cool, nice, never seen that before. I think you can have channel memberships on my channel, but it's not very actively used. So I hope everybody can hear me. I need to figure out how to see everything on the screen, but we'll manage, I think, somehow. Yeah, that is looking fine, I think. But make sure. Harley says yes, can hear. Robert as well. Welcome to the stream. Okay, quick recap. About a month, 6 weeks ago, I don't know, we did a little live stream with the source code of the InfoCom interpreter for the Commodore PET by BitShifter. He made a pretty efficient, small footprint interpreter for InfoCom style games like Zork, etc. For all the 8-bit Commodore machines, PET, VIC-20, C64, C128, +4, plus Apple II, at least it says planned. And while it's a great interpreter, it is lacking some features that I would like to have, especially on the PET. There's also other interpreters for 8-bit machines like Osmu. Osmu, I think, is more powerful. Also supports stuff like the ROI, the RAM expansion unit on the C64. Lots of stuff, undo, scrollback, etc. Colors and all kinds of stuff. But it doesn't support the PET. And I do have a PET here, and I do like the thought of having a machine from 1979, in my case, that is able to run InfoCom style games, because those were never ported back in the day to the PET. Different reasons. First of all, while they are only text adventures, they do require quite a substantial amount of memory. For example, Zork was written on a mainframe back in the day and had to be split into 3 parts, Zork 1 through 3, to make it run on microcomputers of the time. Yeah, and one nice thing about the PET is that you have interesting disk drives like the Commodore 8050 disk drive, which I have over there, which you will see in a second, which supports 500 kilobytes of storage per disk side, giving you, with a dual disk drive, 1 megabyte available without having to swap disks, which is massive, really massive. But the PET has at most 32 kilobytes of RAM, at least the classic PETs. There are versions that have 96 kilobytes of RAM, but those are the very late models, or I think even 128 kilobytes of RAM using bank switching. I don't count them. I want to have one machine from the 70s running 70s style games, basically. My PET is slightly modded. It has one SRAM chip in one of the ROM sockets. The PET has a bunch of option ROM sockets where you usually would put in extra software. Like there were word processors that had most of the code in the ROM, and you would plug it in. You would load up a little stub program which would allow you to load documents, etc. But the main code was in the ROM. Basically also copy protection for the word processor. So you have like 3 or 4 option ROMs, and 2 of those slots, which are 4K each, are being used by this one 8 kilobyte SRAM. And Adalbert or BitShifter already fixed or patched that like a year back, I think, in 2024. For me, for especially this modded thing, because I think this is probably at the moment the only PET that has this mod, to use those 8 kilobytes of RAM as a disk cache, because since you only have 32 kilobytes of RAM and we have, let's check, the interpreter clocking in at 7 kilobytes at the moment for Z3 games and 8 kilobytes for Z5 games, we don't have that much RAM left over. So it needs to read the blocks from disk bit by bit, and there's a lot of disk access. It can't cache so much in memory. So the 8 kilobytes is very welcome in reducing disk access. And the 512 kilobytes on the disk, or 500 kilobytes on the disk, is actually very useful to be able to store multiple games, like all 3 Zork games, on one single disk. That was the idea. And last time we didn't get quite to where I wanted to be, but in the meantime I fixed that like a bit more than a month ago, it seems. And yeah, now we can actually load arbitrary games from disk. Before it would just load the first game file that started with Z3 for the first interpreter, or with Z5 for the second interpreter. And I'm gonna switch over to the PET, which I have to do over here, I think. If I find my OBS session, yes, here it is. And we're gonna turn on this here, and I'm gonna go over there. You will see my hands in a second. And let's check. Okay, Servet also joined. Hello. We're gonna turn everything on. First, I'm gonna turn on the PET. It doesn't matter actually. Getting stuck. And turning on the disk drive, which is blinking. Green light means everything is fine. You can probably see, not quite, but I'm gonna twist this a little bit upwards so that you can see. You can see 31 kilobytes free, basically. That is almost all the RAM there is, minus the 8 kilobytes of cache, which will not ever be counted for BASIC. It is not usable by BASIC directly. This is also running BASIC 4.0, which is, I think, necessary for this interpreter. But that's something I would say is fine. You would normally have BASIC 2.0 on this machine, but BASIC 2.0 is so primitive, and I think people often upgrade it to BASIC 4.0. So yeah, that's fine. We can type directory to look at the disk drives, and you will hear them spinning. And yeah, we do have the interpreter here, and we have Tristram Island .z3. So we can load this by going up here, typing deload, which is the version that I built in the last couple of weeks, from disk drive 0. So this is the game disk, and I also made a save disk, so we can save a game on that, because this is already pretty full with Planetfall, Stationfall, and Tristram Island. And we're gonna load up Tristram Island real quick. So now it's loading in the 7 kilobytes, which is relatively quick. Then we type run, and it will prompt for the game file name. It has Zork1 Z3 as default, but that's of course not what we want. So I type Tristram.z3, and success. It is loading. Now it is scanning the disk. Actually, it is scanning the files and makes a sector map, which part of the story is where on the disk, because it needs to know that, and it will put that into memory, this small-ish thing, and it will pre-populate the disk cache, which is going from 9000 to AFF, which has happened already. loading in a couple of sectors. And I'm not sure what it's doing now. Maybe it's now doing the sector map, I'm not quite sure. The disk drive is working relatively well. This disk drive up here was my bad one, my really bad one. On the inside it was pretty rusted. I cleaned it up very nicely and it's now working. For some reason it, using this interpreter, the disk activity light will stay on even though disk drive is not on right now. As long as this here stays green, everything's fine. It might switch to red intermittently, which means there was a little read error. But usually it can correct. Remember this stuff here is, these are 45-year-old disk drives and 46-year-old machine, so yeah. So there you go, Twisted Island loaded up. You can see it, I think. Yeah. It's a story. You lift your eyes up to the island and sigh. It was just supposed to be a trip like so many you've flown, taking a small airplane to a remote island. Blah 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 blah. I press enter and it is loading up. It says the serial number Inform 636, Puny Inform version 3.2. Loading the first room basically. And you already noticed there's a lot of activity here. We get our first room, the Immaculate Beach, and there you go, and we can do stuff. We can, for example, it says there's a dense forest to the north. Let's try to go there. Maybe it works, maybe it doesn't. The forest is pretty impenetrable this way. Okay, that doesn't work. The beach extends to the northeast and to the west. So let's go west. And I'm gonna look at the iPad to see what's here. So we have one nice machine here. Star Trek style computer. Yes, kind of, right? Okay, now we are at the sandy beach by the forest. The small beach is angled down with small waves crashing periodically on the shore. You can clearly see the high tide line, etc., etc. Okay. To the north is a clearing leading to the forest. So let's try that again. Maybe we can go into the forest from here. So you have to be quite patient with this game. But it's amazing that it works at all. Edge of the woods. Yeah, there you go. But I don't see anything that we can pick up. Now we can try to save the game. Save. And it will ask for the unit 8, which is correct. This is unit 8. We could also attach a second drive and call it unit 9 if we jump at it correctly, so I'll say yes. And we want to try and write to disk drive 1. So I think what I can do, I think I put that in, I call it test, comma, D1. Should work, hopefully. Let's see if I'm correct. At least the activity light is going on. The comma D1 should say, mean that we are saying to drive 1, which seems to be working. Okay, after saving it has some garbage. I noticed that already. So the interpreter is not perfect, but I think the original version did that as well. So that should be fine. We can also try to do a restore, unit 8, and the file name is test.d1. That's correct. It is loading, but for some reason drive 0 is showing up. I don't know. Can we do a look? Does it work? Will the game function? Edge of the woods seems to be correct. So I would currently say that this is working. Okay, good enough. I'm gonna turn this off now, and we're gonna have a look at the code, and we will try to improve on this. So, turning everything off. Gonna switch back to the main screen. Where is OBS? Here. We're gonna switch that off. There we are again. And back to the action here. So I'm gonna turn off the camera here. We can use it later perhaps, depending on how far we get. Okay, back to the code. Where is my mouse cursor? Here. Here's the code. So here I'm in Emacs to do the coding. You can follow along however you like. Code is up at codeberg.org/root42, and then you should see all the repositories and the Zorg PET repositories here, and you can clone it or whatever. Norton Commander, yes, almost. It's 64 copy, which is quite useful because you can manipulate the disk images like the D80 format for the Commodore 8050. That's why I'm using it, but it's very similar to the Norton Commander, yes. So you can clone this, have a look. The two important files are the Zorg ASM and the Z-Inc ASM. The Zorg ASM is the main program with all the fancy stuff for the computer interface. Different parts for different computers. The PET has its own section up here, exactly. PET arrays, for example. Some zero-page variable locations, etc. because they're different from machine to machine. And then you have the Z-Inc.asm, which is basically the Z machine. The Z machine is the virtual machine that InfoCom developed to be able to port their games to arbitrary machines, computers. They didn't have to rewrite the game, they just had to port the interpreter and could run all the games that they wrote for the Z machine. This Z machine itself is basically just a virtual simple machine that can do text in and output, and has the usual stuff, I guess, stack-based machine, I think. And there's a bunch of opcodes, machine code implementation, and that's all fine, I would say. There's also the saving and loading, I think. Yeah, restore games here, for example. And that should work just fine. Hopefully. So what can we improve? I think what would still be useful is to reduce the size of the interpreter. I'm not sure that's easy, and maybe we can only shave off like 50 or 100 bytes, but even that much could be useful because this game, this interpreter is hitting the disk drive a lot. And last time I think we also had the idea of doing stuff like overwriting unused code after loading, something like that. For example, the whole code that chooses the story file is not needed after you loaded up the game, right? That will never have to be asked again until the next power on and loading of the game. That would be one option to also free up some memory. Then we could take a look at some of the macros. I think, yeah, I already did that. I converted the talk function already into a macro because talk is a IEEE 488 function. IEEE 488 is the interface bus that the Commodore PET uses, and it uses these cables, and it was originally invented by Hewlett-Packard, and they called it the Hewlett-Packard interface bus. Can you see that? I'm gonna hold this close to the camera. And as you can see, it says here on the cable IEEE 488 GPIB. Now it's called the General Purpose Interface Bus, I think. It is normally used for lab equipment like scopes, measurement stuff, multimeters, power supplies, you name it. Those used to have all these interfaces. Nowadays you would use Ethernet, USB or something similar. But a couple of those still do use GPIB. Or maybe you still have older lab equipment which is very expensive and are still using it. So you can buy these cables new from China, and this is actually one of the new cables. And you can daisy chain them like so. So it's really a bus. And you can attach another cable here and run it off to the next device. Works pretty well. It is a parallel port, so it is not that slow. Commodore reduced this to a serial port with the same protocol on the 1541 for the Commodore 64, which made it super slow. But what I actually wanted to say is one function that you have on the bus is to enable talking of a device, and there's a subroutine in the kernel of the PET, also of the C64, the VIC-20, and every version of Commodore machines that supports the GPIB or its serial version. And usually you would load the FA is, I think, the first address of the disk unit. So it would load the device 8 or whatever was used into the accumulator and then do the JSR talk. However, with the PET, that is not necessary, because if you look into the disassembled ROMs of the PET, the first thing that JSR talk does is load the accumulator with the drive unit that was used. So that is unnecessary, and this was used a couple of times, like 3 or 4 times throughout the code, and it was redundant. So I converted it to a macro with a conditional compilation. If we are not on the pad, we will load the first address, otherwise we'll skip that. That will free up, I think, 2 bytes times 3 or 4, so we saved 8 bytes or something. And that's the amount of saving that we're talking about. So, also, my caveat as usual, I don't code 6502 assembly, so I'm learning as we go. I do know a little bit, I do understand the roughly what the opcodes do, because they are actually rather simple. But I never actually actively coded 6502 assembly, so yes. I might be writing not very optimal code and trying to optimize existing code. Yeah, let's see how that goes. So, what we can't do and don't have, Robert says, do you know if this interpreter actually takes advantage of all available RAM? Yes, it does. Yes, it does. Especially, I think it requires a PET with 32 kilobytes of RAM, because even the smallest InfoCom style games require 32 kilobytes of RAM. And it has the auto detection routine for the extra 8 kilobyte of soft ROM SRAM that I put in there. There's a detection that tries to write at those addresses, and if it detects, oh yeah, I can write there, it will assume that there is the cache memory available, and it will do some disk caching, put a couple blocks from the disk in there, and then you will have less disk activity, but still a lot. So every byte that we can save in RAM will be good, I would say. Actually, what might help is that we take a look at the listing, which the assembler generates, I think, from the source files. This should, I think, be the actual code that gets generated. Not quite sure where this all ends. I think here's the code. And then there's some if else whatever. That is disabled. Yeah, okay. This is, I think, the pre-processed source file that falls out of the assembler. The assembler that we're using is a BitShifters assembler called BSA, which is open source, so you can also download it. We have a make file which assembles everything using BSA, which is in my path here. I just compiled it also, so you can download BSA as well. It is somewhere on BitShifters GitHub.io, I think, maybe here. No, on GitHub, probably, yes. No, that's not the right person. BitShifter BSA, let's look at that. Here, Edelbert, that is him. That was a different BitShifter. Yeah, that's it. So you can download the assembler. You need that for compiling this. And it's pretty simple. You can just run it through a standard C compiler and be done. Like CLang on macOS or GCC, whatever. So that should be fine. So we can just type make to assemble everything, but we're already done. Okay, so it will output these list files, and we should be able to see here what it actually produced. Let me remove the Z3 pad and make it again, because I think otherwise we are looking at the Z5 version probably. Yeah, Z machine version 5. Or do I have to create it manually? Yeah, I probably have to produce the lists. Ah, no, it's called zorg.list. Oh, I'm looking at the wrong one. Okay, yeah, let's open zorg.list. Which is also Z machine version 5. Why? Did we produce something that I didn't want to produce? We defined the Z machine version to be 3. We defined PET to be 1, so that it builds the PET version. And that should be it. Z3 PET is being generated, and it's smaller than the other one. So maybe ZV is still set to 5 because, I don't know. Let's look at the assembly file. I think it's because it's in the source code, right? And it can override that. Because PET is also equal 0, so it doesn't reflect the command line settings. Okay, fair enough. I can live with that. Let's redo that. We do see here the command line defining the Z machine version to be 3 and the PET to be 1. That should generate the correct one. Fine. So what else do we see? The 0-page variables. Yeah, here it says if PET evaluates to true, so ampersand equals $11, whatever. It seems that this is some kind of instruction for the assembler to use these as the 0-page variables, and you can't use any lower because the PET uses the lower ones already for some purposes. And here it says skip because there was the else path that was not taken. Okay. Then there's a bunch of variables for the interpreter, I think. Current code byte, Z code, and then there is the byte 0 PC. PC means program counter, I guess. Floppy block low, floppy block high. RAM address low and RAM address high. I guess these are status variables for the interpreter, for the Z machine. And then there's data pointers. Current pack data low, current pack data high. Then again a program counter, floppy block, RAM address. Okay, I'm not going to touch these because I don't understand them yet. No idea what they mean. And then there's a bunch of other variables. Multipurpose local variables. Okay, who knows what they are for? LV0 through LV3. Alphabet, block low, block high. The low and high variables are usually 16-bit values, either pointers or pure values, because the 6502 obviously is an 8-bit machine with 8-bit values, but sometimes you need 16-bit values, like the address space is 16-bit, so that you can address 64 kilobytes. And that does make sense, I would say. Cache index, cache size, cache start and end. I guess this has to do with the disk cache that you are also using. That would also be something interesting to look at, because I don't know how the disk cache works. And it would be interesting maybe to figure out what is the most efficient caching strategy. Does it use least recently used, or first in, first out, or I don't know. What strategy does it use? Is it actually, can we measure the difference on the machine, on the real machine? If I unplug the SRAM versus I don't. I'm not going to do this experiment today because I think then we'll get stuck in benchmarking, but that might be interesting to see. And then to maybe use different caching strategies, right? There's a lot of other stuff here. And I think the PET code also here has support for other PET machines that have more memory, like also multiple RAM banks with bank switching. That is something that we could actually disable for our own build here. We could build a version that runs only on the PET 3016 and similar. Well, mine is a 3016 upgraded to 32K RAM, but like only the older machines, which is fine. It's, after all, this interpreter at the moment is only for me. And you can still use the original version, which has support for more varied machines. Not quite sure how much that would actually change. Let's see if the RAM bank, for example, is being used somewhere else. It does say if C128 or PET, and it evaluates true, then it does some RAM bank selection. But that's something that we could already disable, right? Here again, it has the code for RAM bank 1. Oh, that's interesting. Yeah, we could put in a if command for banking support, and we could disable the banking support. Let's try that. I think that could give us quite a bit of memory, actually, a couple of bytes. Zorg.asm and RAM bank. Can we, what is RAM perm low and high? I'm not quite sure what is that about. Okay, let's start small. Let's start with the RAM bank. So instead of if C128 or PET, we could do something like if banking. And we could set oh sorry, let's put it down here, something like that. A new if pet bank to something, yeah, banking, exactly, something like that. Support bank switching for more than 64K RAM. Julien de Rivière has joined. Guten Abend, everyone. Sounds French, speaks German. Interesting. And Germany beat France yesterday, I think. I watched the last 2 minutes plus the penalty shots. It was very, very stressful. Missed the whole other game, the rest of the game. So, sorry for your loss. Let's see how that continues. Okay, banking, right? RAM bank. I would also take out the variable here. If banking, I think end if or something, right? I don't follow football either, but I was curious because I read someone posting, oh my god, it's so crazy, and then I watched the last 2 minutes. Okay, here's the banking. Then we have the here, this is also if banking. It's a subroutine called fill bank 1. And that's fine. If pet disk to RAM, it is loading X with RAM bank, but I think we can probably do something like if banking, then we do this, else we load X with, does it make sense? Hash 0 is literal 0, right? Or am I doing something completely redundant now? What does the code do here? It loads the RAM bank, the current RAM bank, into X. Then it's setting something. SEI sets the interrupt disable flag. Okay, so that no one messes with us and switches the bank, perhaps. Then it stores the RAM bank into FFFZ. This is doing some bank switching, I guess. Let's look at the pet memory map. Here maybe on Andre's page, maybe kernel ROM. Yeah, do we have the exact? We need the disassembly, I think. Damn it, where's the disassembly? I closed everything. Pet kernel disassembly. We need that. ROM disassembly. No, not for the C64. We need it for the pet. Here maybe. Pet ROM 4.0 disassembly. Yeah, that's what we need, I think. And it's writing to FFF0. FFF0. Yeah, that's probably That's probably nothing on this version and is probably the bank switching on the larger models. Do we have something like PET 8296 kernel disassembly? Something like that? No. I'm gonna go out on a limb here and say that's exactly what's happening here. And I think this is doing exactly nothing on our machine. So I would say this whole thing can be disabled because it is storing the RAM bank into FFF0, storing the accumulator into RAM low, Y, then loading 0 back and switching back to RAM bank 0 and then enabling interrupts again. Does it make sense? I think it will still run fine on our machine if you don't need RAM banking. On the C128 it does seem to work differently, so we can ignore that, and that's it. So now let's have a look. Before we were 7169, okay. Gonna run make and fill bank 1 equals undefined. Okay, line 2050. Ah, yes, okay. Fill bank 1. Okay. If PET. How do I do an AND, or was something like this? Do I just write AND banking? Maybe? Let's do it like this, I guess. Yes, it seems. So 7169. 100 bytes! Almost! Yeah, I could nest the ifs, but I thought, meh. That's 100 bytes right there. So let's see if we can, if this still runs. There, and we need expat. There we go. Then we need to attach a disk. This one here, right? Yes. Let's have a look. Directory. Does work. Let's go up. Deload. It's very, very, very realistic by swallowing some key presses. I think there's quite a couple of people inside the stream. Very nice. Welcome everybody. And yeah, we're gonna load up. But it's there. I think we broke something. No Z3 story. Oh my god. Reset was Command F12. Damn it. Did I break it? Did I break it? Did I use the correct disk? ZorgPad. Yeah, that's the right one. That's the correct one. I dislike this. Okay, it doesn't like that if I don't put a colon, not a semicolon. So run. Zeisorg2 Z3. Okay. Doesn't work. Fair enough. I hate it. Okay. Let's roll back those changes. Let's stash them. Banking optional. Let's call it that. Okay, that has been stashed. Let's remake this. Let's now we should be back. Yeah, we are back to the original size. I still think we can make this work, but we probably broke something. It might be only this variable that I need to adjust something if I leave out that variable. I do imagine that could be an issue. Okay. I think we were at 28 blocks just now, and now we're back at 29 blocks. Yeah, okay, that works. Okay, so definitely the stuff that we made it worse. So we pop the stash, banking optional. Here's our changes again. One thing that I want to test is if the RAM banking produced something that was not what we want to happen. All right. Gonna try again. Uh, 1790. That's the same size, right? Okay, I'm not convinced that this will be fine. Do I have to reload this? I'm not sure. Maybe that is even unnecessary. But we are one block smaller, so this is definitely the updated version. That's good. Loading. Ready. Okay, no. We need to do something. Something that we did was necessary. The question is what? So we can re-enable this here. I'm wondering why our code doesn't get 1 byte smaller if I make this optional, this variable, because I think, or is .bss in RAM only and not in the binary? That could be right. That this is inside of a data segment or something. That could be the case. Let's see if I make this. No errors. It stays at 1790. Okay. Only the listing changed size, which is fine. So this seems to be in RAM somehow. So let's have a look again. What did we disable that broke it? I don't think it's this here, because maybe fetch bank 1 needs to be changed too. Might be tricky though. My data segment may be rounded to 2 bytes. Yeah, that's also possible. Maybe. So let's go through all the changes. If banking, here is I think safe because it loads the RAM bank that we have. There is. Look at this. If C128, and there should be something for the PET as well. Switching value for bank 01. Okay, but these are only constants. I think those don't take up any space. So this loads the constant for RAM bank 0 and stores it in the variable RAM bank, which we are not using. So we should be fine. Then we have fill bank 1, which we disabled now. What does it do? Print RAM bank 1. Is this debugging? I guess it's a debug macro, maybe? Can we search for print macro? Yeah. This is not conditional, right? Print macro always prints, right? What does star equals 0 mean? Some parts of this assembler are a bit are not very obvious to me. Either way, are we here at the right place? No, this is what where we were before. So it prints this wherever, then jumps to subroutine save cursor, which makes sense, I guess. Loads the accumulator with RAM1, which is a constant, switches to that, I guess. Loads the accumulator with the high byte of RAM disk start, I guess. Jumps subroutine load page. Ah, okay. I do understand, I think, Robert. If this actually does initialization of the RAM, even without RAM banking, it would produce an error, I guess, but I don't think that's necessarily what's happening here, because this was originally, let's look at the diff. This was originally only on the C128 and the PET. The whole fill bank 1 routine. So I think we should be able to live without it. I'm still convinced we should be able to live without it. But let's see where fill bank 1 gets called and what other people are doing around there. Load resident area. Yeah, that's, I think, part of the game that gets loaded. There's a resident part in all InfoCom style games that is always in memory. That's why it's called resident. And I think this has to fit all in memory. What about this? Is maybe this why I'm failing? Because this is PET specific. The start 09 is a label in the startup routine, obviously. Bit does what? Bit does what bit does best. Bit does a bit test. Okay. This instruction is used to test if one or more bits are set in a target memory location. The mask pattern in A is ANDed with a value in memory. Okay. Okay, this is basically an AND without keeping the result. In A, and A has block low, and it compares to cache AND. So cache AND is 8,000 hex. All right. Yes. Yes. Fine. Does this make sense? I think I'm gonna try to just if this here, just for testing. Robert says, looks like it continues at start 09 either way, just skips fill bank 1 or not. Exactly, for some reason. But maybe it sets some flag that but actually the BVC is the point, like a JNC basically. Yeah, that's true. Actually, that should not change anything, right? That shouldn't change anything. BVC is branch if overflow flag clear. Oh, interesting. Bit can set the overflow flag? I didn't see that just now. Set to bit 6 of the memory value. Ah, okay. Bit 6. What is bit 6? Let's check. Bin 10000 and hexadecimal is 20. Okay. JNO. What is JNO? Jump not overflow, basically. Okay. Yeah, okay. So this shouldn't change anything, right? I'm not convinced. I'm not convinced. Let's go back to this version and think once more about it. So this here is only for the C128 and banking support. This year, if PET and banking, that was what we were writing. This will test the block low, because that's in the accumulator right now, I think. Because this doesn't change the accumulator, this doesn't change the accumulator, this doesn't happen. So this compares or ANDs the value of the accumulator, block low, with cache AND. What is block low? Some kind of variable that's probably set by swap in. Swap in is doing something with the cache. Okay, it's okay. First page in RAM disk. Yeah, because we don't have a RAM disk. Yeah, right. I think it was that if you have extra memory that can be bank switched, it is used as a RAM disk, which is different from the cache. Interesting enough. Not sure how the cache works versus the RAM disk, but the RAM disk is different. Okay. Okay, there's a lot of stuff here. Compute buffer pointer position from block, blah blah blah. Okay. Fill bank 1. So this should not hurt us, I think, right? If we disable that. But somehow it does. My assumption would be that we never call fill bank 1. Or do we? That's a good question. Disable the calls to fetch bank 1. Yes, because otherwise it wouldn't work. there's only one call, only there. And I think in Z-Ink we should be safe, because I think that doesn't use, yeah, that doesn't use anything of that. Fetch. Oh, sorry. Fetch bank 1. No, thank you for pointing that out. If banking let's do it like this. Banking. And another one. Banking. I love the name 910. That's brilliant. Okay, now it's all off. Thank you. I didn't see that at all, but it does make sense. Probably now it's smaller, even smaller. 742. That's nice. Okay. That of course would make sense if there's nothing in bank 1 that there should be. But why do we have bank 1 at all? Well, we don't have any bank 1 on this machine. Let's see. It's still 28 blocks, so we didn't save another block, but it has gotten smaller. I'm gonna be very lucky and just load it without reattaching the disk image. And if it fails, I will reattach the disk image, okay? Because I think it will have loaded the new content. Okay. Let's try to reattach the disk image. The annoying bit is we don't know if it's actually the new version because it has the same size. Anyhow, no, that didn't work. We still broke it. Damn. Next datum. So we have, let's look at everything that contains bank 1. And there's not much. There is not much. We have 6 matches. We have this year fill bank, which we already disabled. This is the second hit. This is the third one. It is the jump subroutine to fetch bank 1. Hello. Hello, soul sister from the next room. I'm still wondering, why does it change anything if we don't have a second RAM bank? Where does it fail? Why does it say no story? So it probably says no story because it doesn't, we don't even get to the loading of the blocks or parsing of the file, right? And that is a bit weird. Oh, it's loading them into the wrong memory location. But we don't even see the screen, right? It stops right away. No Z3 story. Let's see where this is being used. It happens here. It does the... We're using the rel file, I think. Are we using the rel file? I think it doesn't matter much. I think here we are seeing it as a... Oh, come on. It's a PRG. Yeah. And it did work, so we saw that. Input story file. Okay, yeah. Input story file was what we're doing, asking for the story name. We are searching for the story file. Doing this here, whatever. Storing accumulator RAM high, and then doing the load page. Load accumulator H version. H version is probably some kind of variable. No? What is it? Where does it come from? That's the, okay, that's in the file, the very first byte in the file, in the header. Disk to RAM having some banking code in it. Looks like it calls load page to load the first bit, which calls disk to RAM, then it checks for valid Z3 image. Okay, that makes sense. So let's go to load page, which is here. Block low, block high. Next record, disk to RAM. Here it is. Disk to RAM. If banking, yes, that is what we disabled. So what is actually maybe we disabled too much here because what if this thing here is actually doing something useful? What is RAM low? RAM address for disk access. Okay, maybe that needs to be actually set, right? The RAM address is determined by RAM low, y, and maybe RAM bank. So I think we probably disabled too much here. Loads X with RAM bank, and I think we probably need this part here. I think this here actually needs to be here, because this seems to be just the switching of the RAM banks, and this is the actual business logic for the PET. Because that's also what's happening with the VIC-20 and the +4. Alright. Let's see how it looked like in the original. Oh, come on. No, that's a bit annoying. Let's stash everything again. I'm gonna pop it in a second. It was if PET. Okay, if PET and banking. Let's do it like that. So pop the changes again. If PET and banking. If PET and banking. I think this will work. Good grief. 7044. That's 2 bytes, which is fine. 28. The star line could be only if PET. Yeah, that's true. Okay, there we go. D0. Oh, come on, come on, come on. Run. Success! We saved 100 bytes. And it will only run on, or it will run on all the pads, but it will not use the RAM disk, which we have here at 8000 hex. There's also no, yeah, it has a cache. It has a cache at 5600, which on my machine would be at 9000, because there's the soft RAM. But it's not used here because I don't emulate it. I think I could emulate it here, but I didn't do it. Yeah, seems to be working. Open mailbox. Let's see if that works. Hopefully, if no more drink. Seems fine. Awesome. Good, good. Can we make it nicer? What Robert said. Basically, oh, this is actually bad, because this is actually being compiled. This should be for the pad. So that is actually if pad. That was what we had there. And then we need to do it like if banking and if. And then again, if banking and two and ifs. Okay, right? Right. We can turn banking on by default. I'll do it like so. Then open up the make file. And so that it's clear that it's only for my stupid games, we do banking equals 0. Something like that. Okay, I think that is quite nice. Disk to RAM. That was this one here, yeah. That should work fine. Good. One more test, if it still works. Deload Z3 pad. Run. Yeah, still works. Okay, cool. We can commit this, I think. We are on main. Yeah, let's stay on main. It's committing to main is fine, right? It's after all, it's my fork, so that's fine. Make banking or bank switching a compile time option. And push the commit. Yeah, here we go. It's pushed, it's off, it's shipped, it's fine. What could go wrong? Actually, I think we broke the C128, maybe? Maybe? I think for the C128 we should also do the if banking. It does the stash thing. We probably broke something more. I'm not sure. But this can't work because it's disabled on the C128. So for future, we would need to set up builds for everything. Who has a C128 anyway? That's true. Yeah, there needs to be some cleanup and some. We need to build all the machines and test them. Stefan says, if you don't break it, you don't push hard enough. Yeah, sure. I have a C128. Stefan actually sent it to me a couple of years back. It's still sitting unused, and I'm still promising I'm gonna clean it up. It is getting new fan. It is getting complete cleanup and whatever. It does work, but it's super loud. And I didn't get my guts to actually make something with it. But it's a lovely machine, and 128K of RAM is definitely a good thing for InfoCom games. Anyway, there seems to be some issue with this stream. It's still working. I get at least I get an issue here. Stream status is bad. Are we still audible and watchable, or is it somehow? I'm at 6 megabits outgoing. Shouldn't be too bad. Anyway, okay, this all works. And I think, yeah, let's play around a bit. Maybe we can test the C128. Okay, everything fine. We can test to build the other versions, maybe. Just so that we see if it still works. Perhaps. Do I have the X128 emulator running? Yeah, seems so. And for everybody wondering, the C128 has two screens because it has two different outputs, one 80 column and one 40 column output. So that does work. Let's try to build that. Let's enhance the, let's only do the C128, the Z3 version, I think. What is the machine here? C128, okay. C128. And it should produce the correct output file, I think, by itself. And the C128 was built? No, it wasn't, right? I don't see it. It built the PET version. And it built another PET version, but nothing else. Why? What did I do wrong? You need to add it to all. Thank you. Thank you, of course. C128. And let's also add it here. I suspect there is something, some makefile magic that I could use, but not today. Okay, there's something wrong here. Let's go to white space mode. No, this is a tab. This is also a tab, that's fine. What did we do wrong? Oh, of course. I mistyped. There you go, there you go. Okay, now we have the Z3's C128, which we will now have to put onto a disk. A disk that we'll create using some function here. How did that work? Format image. There was some make image, F12 here. We're gonna use a 1541, even though 1571 should also work for the C128. Oh, let's just do this one here. Let's call it Zork D71. Here it is. Then we will put the interpreter there, and we will put the Zork files. Yeah, let's put the Zork files over there like so. Enough space. That's nice. And then we go to the C128 interpreter. Attach a disk image to drive 8. Oh, wait a second. What is actually our machine peripheral drive here? It's a 1571 cost reduced. Yes, that's fine. True drive emulation is on. Attach disk image, and we're going to home. Why does this not work? Oh god, I hate it. Let's open a Finder here. That should be fine. And let's just drag and drop this. That should hopefully work. Where is it? Where is it? Where is it? Up here, because it's the newest one. Okay, that does work. Okay, this indeed looks like everything is in normal RAM, I would say, right? Maybe? It does say RAM bank 0. It did not fail. It doesn't say RAM bank 1. And everything here is below 64 kilobytes. So I would assume that we successfully disabled bank switching. Okay, it doesn't work. And I think I know why. Because that can't work. The cache is overlapping with, or the RAM disk is overlapping with the cache. And the RAM disk is also overlapping with the story. So yeah, we broke it. Never mind. Let's do a test if I enable banking for the C128, if it at least works, if we didn't break that. Yeah, we could make it so that on the C128 it doesn't make sense to to disable banking. That's for sure. Oh, make clean make. So let's delete this and let's copy this again. Now it's bigger again, of course. Yeah, that's for sure. We should refactor that to reflect that. Yeah, let's do warping. Oh. Ah. Oh, yes, okay. Okay, fine. I think I'll do this off screen because I want to close the stream in 5 minutes. I think we were still somewhat successful. We shaved off 100 bytes from the PET implementation for all the PETs that don't have more than 64 kilobytes of memory space, which is fine, I think, which is like all the older PETs that are not modded. I think you can make a mod with bank switching, but it was rather uncommon. But basically all the 30 and 40 series of pads, and also the 80 series, not the 82 series, but the 80 series of pads did only have 64 kilobytes of address space, 32 kilobytes of RAM, and then 30 kilobytes of optional ROMs. So that's fine. Yeah, I think I should not have pushed the changes already, but I will fix that. I will make the banking so that the C128 always banks and the PET only if needed. So yeah, I think that should be doable. Oh boy. Anyway, this is starting to become a pretty nice thing, I would say. 7 kilobytes, maybe we can squeeze it a little bit more. I don't have high hopes that there's a lot to be shaved off, but if there are other features that the base PETs don't have, we can actually, I think, make it even smaller. And the next thing that I also would like to see is what does the cache do? How does it work? Is it something useful? We should find the soft ROM thing here somewhere. Exactly, I think this is the test. If there is, this is the test for the RAM at address 9000 hex to AFFF. This is the 8 kilobytes of RAM, SRAM that you can have, which should be used as a cache, which is nice if you have that. And the question is, how does this whole cache stuff work? And yeah, I will clean that up offline, and we might have later in this year another Let's Code session to optimize this further, and I'm trying to fix the C128 so that it works again. And we should also perhaps try and get a build pipeline running where it builds all the different versions, and maybe you can even run the emulator automatically to check does it load up or something. Maybe you can do some kind of regression testing. I'm not sure if you can, I bet Vice has to have some kind of scripting capability, because I think they need to be able to do that with their emulators, right? I think they need to be able to test that with all the emulators. They don't do manual QA all the time, I guess. That's way too complicated. So if we could get it to run like the assembly and then run the interpreter with the Zorg1 image and see that it runs and ends up at a certain screen state after simulated cycles, that would be nice. Having the makefile build complete disk images itself would be useful. Yes, indeed. That is actually not that hard. There is a command called C1541 from the Vice team, included with Vice, that is scriptable. And here I have now just the command line interface, but you can pass it commands on the bash or a CMD in Windows to create and assemble disk images. Very simple. So that is definitely scriptable. That would be nice to have. Yeah. So we optimized something, we broke something. I think that's already great. I do understand a little bit more now how the interpreter works. So there is a bit of magic happening with the RAM disk and the stuff and the banking, but I'm still a lot unclear about all the structure. It seems to be, I think it's cleverly programmed. It is already pretty optimal, especially in supporting so many different platforms. I mean, I think Adelbert tried to make the code very readable, even though you have stuff like if PET, if C128. So it is a bit hard to wrap your head around the platform-specific things. But still, it's pretty impressive that he managed to do all that. And as I said, for all the other people, I definitely, if you don't want the PET InfoCom interpreter, I definitely can recommend Osmo. There's osmo.online, so you don't even have to build it yourself. You can either pick one of the provided games that they have here, which are basically all the InfoCom games that do work on the small systems, plus a ton of puny Inform games, which you can also buy commercially. Then you will get Osmo already on a floppy disk, but you can download it for free here as well. And then you can pick a machine that you want to build for, Commodore 64, 128, plus 4, Mega 65 or Commander X16, with a disk drive setup, like you have a single drive or you have dual drives, or you want one disk or two disks, you have a RAM expansion unit on the C64, for example, and stuff like that. And you can just click build for C64, and then you can download the disk images that you created. You can also set the text colors, etc., etc. Very nice. And then you get your ready-made disk image for your emulator or your real system. And that's pretty nice. And I think Osmo is definitely better because it is targeted at the bigger machines, let's say. And Adalbert's InfoCom interpreter definitely runs also on the very small machines. As you can see, this here doesn't even support the VIC-20, and Adalbert's interpreter also supports the VIC-20 with the 32K RAM expansion, which makes it basically a PET with less characters per line, let's say. But that's it. That was 1.5 hours of stream. I think that's enough for today. Thank you very much, and I'll try to clean this up before the next stream, hopefully. And then we can work on the next things. The caching strategy, to see if how that works, if we can make it run even faster on the pad. So my goal will be that we have a super fast interpreter that hits the disk as rarely as possible. Because that is where the games get slow. Every time you type a command, it needs to access the disk, and maybe there are strategies to help with that, and that would be my dream if we can do that. But I mean, having 40 kilobytes of RAM is not a lot if the game file itself is like 100 kilobytes or something. So yeah, so we can't have miracles, I guess, but we can try and squeeze everything out of there. Okay, that's it. Make sure to subscribe. I have a ton of other videos about coding, about tinkering with these old machines. Yeah, just have a look, and you can also join me on Mastodon at chaos.social/@root42. And I post mostly retro content there, or boost stuff, things like that. You don't even have to register yourself on that. It's just a website, so you can just browse it and have fun. But if you want to connect, that's where I'm mostly at. So just create an account on whatever server you want and follow me, and I'll maybe follow you back if you have interesting stuff. And yeah, I think that's it. Have a very nice Sunday. Have a great start of the week, and see you. Bye.